Okay, here's our function, and we are trying to find f of 0, f of -3, and f of 5. So what this means is we plug the 0 into where the x is at in the original equation. So for this one we have 0 squared plus 5, and we would just get an answer of 5 because 0 squared is 0. For this one, you have to make sure you put the negative inside parentheses before you square it. So what is -3 squared? 9. So this should be 9 plus 5, which is 14. If you did not put the -3 in parentheses in your calculator, if you were using your calculator instead of just doing it off the top of your head, you would get a -9 because the calculator would say, oh, you want to square the 3 and then put the negative in front of it. That's order of operations. That's not what this function is saying. It says square the entire number that is given. For this one, I have 5 squared plus 5, which is 25 plus 5, and the answer would be 30. Right, a piecewise function is a new type of function, and it happens in a lot of instances in science when things change as a value gets very large. So for the first example I have f of x being two different functions. Sometimes f of x will be -x, and sometimes f of x will just be x. And it depends on whether the x value is less than 0 or the x value is greater than or equal to 0. So the way you read these is you have to come at it backwards. You have to, when I give you the x, you start over here and see which line your answer is going to be on. Right? And then you go back and pick the correct function, function 1 or function 2. So for example, if I ask you for f of -4, since -4 is less than 0, I would go to line 1, and that would mean it's equal to negative of -4, which would be 4. Okay, so you take the x value that you're given, remember the x value is here, you look at the little constraints over here that tell you what you do for which x value, you pick the right group, and you do that one. So if I say f of 0, that would be the second one. Not that it would matter in this case. It would just be 0. F of 4 will go to this second one. And that would just be 4. Okay, f of -3. The first thing you have to do is figure out which one of these three equations you're going to use, which one of these relationships works with -3. You go over here and you find the top one would be where the -3 would be. So I am going to say that's equal to 4 minus 5 times -3. You notice in the past I've had when I've had this, Kids think if I put a -3, you have to do all three of these. You don't. You just do the top one, because this says which one of these rules you use. And so this would be 4 plus 15, which would be 19. Okay, f of 4 will be in the lower one. And so that means I'm going to take the x value, square it, and then add 1 to it. So that would be 17. And the last one I ask you to do is f of -1. That would fall in this middle range right here. And so the answer is 0. The way these end up looking is very weird. They go along for a little while and then they stop and they jump to a different place. And then you have a different graph, and then it jumps and it does something else. The key over here is that you cannot have the x's fall into two different categories, correct? Or else this is not a function. So this over here has to incorporate the entire x axis, but break it up in ways that any value could not be in two different pools. Okay, this right here, this part right here, is f of x plus h, correct? I'm about to lose power. And then this part over here is minus f of x, correct? And then I'm going to divide this whole thing by h. Alright, what do I get when I do this? It is not x squared plus h squared. It is x squared plus 2hx plus h squared. Remember, this means x plus h times x plus h, so it's a FOIL problem, and the inside and outside terms are x times h, so you'll have two of them. Okay, this I can just go ahead and distribute the negative through. Minus x minus h and a plus 1. Distributing the negative through to all of the f of x gives me minus x squared plus x minus 1. Now we start, and it's all over h. I'm going to leave that off. You can cancel the 1s right away. We see that? Cancel the x's? Yep, I can. What else can I cancel? X squares can cancel. That's it, isn't it? Okay, so the top comes down to 2hx plus h squared minus h, and then it's all over h, because this was all over h to begin with, but we just kind of left that alone. Anybody see something you can do now? Yeah, what can I do on the top? I want to do something first to make it a little prettier before I cancel. Because I can't just cancel this and this. I could move the h squared to the front. Okay, let's do that, because you're right, I don't like it looking like that. Alright, h squared plus 2hx minus h over h. That looks prettier. What do you notice about the top? You can take an h out. You can factor an h out. Alright, so when I factor an h out, I have h out in front, h plus 2x minus 1, and I divide it all by h. Why was that a nice thing to do? Now the h's cancel out. So notice at the beginning I said h cannot equal 0, and that is still true. H cannot equal 0 because this right here, because of what I'm doing right here. Right? I'm dividing by h. However, my final answer has h plus 2x minus 1, and I have no chance of dividing by 0. I still have a hole in the graph at 0. However, the graph comes right up to it, jumps over it, and keeps on going. Right? It doesn't make an asymptote there. So we're going to talk later on about asymptotes and non-asymptotes.